So it is possible, and you'll see some stuff like this on the assignment. In fact, on X, we're going to change this just a little bit so it kind of reflects the assignment. We're going to put a v times x to the power of 2. That's very abstract. There's no numbers, but we've solved literal equations like this from Unit 3, I believe it was. Maybe it was Unit 1. Could have been Unit 2, whatever. Right? Let's start with S. So these are equations that we need to solve, and we're just going to use principles of equality to solve them. So on this one, the first thing, remember, just the same thing like we did when solving for just a regular x. Like if that didn't have a power of 2, what would you do to solve it? You'd have to subtract 16 from both sides to isolate the x, which makes that a 0. Remember, that's how we get those phantom zeros. Drop your x to the power of 2. But now e equals 25 minus 16, which is old 9er. Then take the square root of both, which gives you just x, and the square root of 9. You could type that into the calculator, but you're going to get 3. Now remember, that was an x to the power of 2 equals the square root of 9. There's more than one answer, not just 3, but also negative 3. 2 answers on this one. You know, we'll do u while we have it up on the screen. So on this one, it's 10 times x to the power of 2 equals 1,440. Divide both sides by 10, right, to isolate that x, making that a phantom 1. That gives us x to the power of 2 equals 144. Square root both sides to make that just x. And what times itself is 144? Just 12. But again, that's an x to the power of 2, which means that not only 12 would make this a true statement, but also negative 12 would make it true. 2 answers. All right, t, we're going to work the same way on t. So I need to just make that an x to the power of 2, not minus 5. Got to zero that out. So I'm going to have to add 5 to both sides on this one. It's going to zero out that negative 5. Drop your x to the power of 2, which now equals 59 plus 5 is 64. We've seen this already, so when I take the square root, I know that x would not only equal 8, but also negative 8. So again, if you replace that in there, 8 times 8 is 64, minus 5 is 59. Negative 8 times negative 8 is positive 64, minus 5 equals 59. So both those check off. And then part V, divide both sides by 2. Again, that's to make that a phantom 1. So x to the power of 2 equals 16 divided by 2, which is 8. Let's square root both sides. We've seen that before, though. We can still show the work, I guess. So 8 would split up into 4 and 2. 4 splits up into 2 and 2. So it's really the square root of 2 times 2 times 2. But we're looking for pairs on this one, so there's a pair of 2's. So that's a 2. This other 2 stays in the square root, and that's our value of x right there. Now, since it was a power of 2, not only would it be this value, but also negative 2 times the square root of 2 as well. All right, for a problem like W, you're going to need to multiply both sides by 2 to get rid of that divide by 2. By get rid of, I mean a phantom 1. So that's y to the power of 3 equals 64. It's a good value because when we take the cube root of this, and you could put this one in the calculator, or you could look at the poster and see that it is a perfect cube. That gives us y equals 4. Now, since this was a power of 3 on this one on W, we do not make it 4 and negative 4. It's just 4. And then part X here, just to go back on this, please recall that we don't really care about X being a positive, or P being some kind of positive value. We're just solving in this one for X, okay? So to solve for X on this one, we'd have to divide, and I did change the problem, remember? So we're going to have to divide both sides by V to isolate the X to the power of 2, so that becomes a phantom 1. Now we get x to the power of 2 equals p over v. But to solve this one, to get rid of that power of 2, we'd square root both sides. Okay, so that gives us x equals the square root of p over v. These don't really represent anything. P doesn't really mean anything, neither does x or v. It's just an abstract, general, literal equation which we've solved before, so you should remember how to solve these.